So, inside lesson 1 lab, we will be using the feature extraction techniques we have already learned to classify news articles into different categories. So, the dataset contains news articles that has been collected from different sections in the Guardian API like business, politics, lifestyle and all those sections. In here we will design a classifier using SVM classification method, so that we can classify them into their respective sections correctly. So, we will be focusing on lab 1b.py file that uses SVM classifier with a linear kernel. Yes, SVM classifier with linear kernel. There are some other 2 example files which uses different classifiers basically, and again we will be starting using the Guardian 2 text articles that we have already collected. Again, this is the each article contains a particular story or the news, and they have in their name associated the particular section they belong actually. So, let us focus on the lab 1b.py, but before doing that we will run the program, so that it runs in the background while we explain the. It is very simple to run, like you can right click on lab 1b.py and just click run, it should work. So, again we are considering the Guardian 2 folder as our training path, from where we will read the files, and we have these sections which are mapped into integers, like environment is mapped and represented with integer 8, business represented with integer 1. We are reading the files from the directory where the training files are available, that is Guardian 2, and we are appending the content of the file to list of documents, and we are also appending the section name or the section ID. Like if you find that if it is belongs to environment, we will try to put 8 in the list with this corresponding to this mapping. Here we are trying to make the documents lowercase, so that there is no case sensitive issue happens, and removing unwanted spaces and just doing some preprocessing task. Again doing some preprocessing task by replacing multiple spaces into single space. Then we use the bag of word, extract the bag of word feature with the vectorizer, which you will be able to see in declared. It is a count vectorizer, and it also includes the stop words English. So, it will be by default removing the stop words from the list of words available. So, we are extracting the bag of words feature. So, it will be a 2D matrix where each 2D is it is a 2D vector where each vector will be representing a particular document. Here we are just randomly doing some shuffle on the documents and on the labels. Then we create an instance for SVM classifier with linear kernel, and we call the cross validation score using it as a classifier, and using the feature bag of word features as the feature attribute, and label as the listed labels from the class attribute array. Then we will be able to see the cross validation accuracy. You should be able to see like 5 different scores, because you are like running 5-fold cross validation, and later you will be prompted to give a input on a particular article ID to see what is the actual level of the article and how the classifier thinks the article belongs to which section. So, yeah, it is already showing the cross validation accuracy it's like around 7.7, and if you put some particular document ID, it will show the content, and along with it will show the actual level and the predicted one. So I am taking 24184 24184 underscore business 24184 business. This is the content of the file, and actual predicted level is business and actual level is also business. So in this case the classifier actually predicted it correctly. So So if any one of you want to see how logistic regression will perform on this scenario, you can run the lab1b logistic.py, where the classifier being used is a logistic regression model. Similarly, the lab1b svm underscore rbf, it uses rbf kernel instead of the linear one. So I am moving to the lab 2 basically. So inside lab 2 you will be using different classifiers with malware dataset. Similarly, we have learned how to extract n-grams and 1-grams from malware data, byte data, that will be useful in this scenario, in this section. Sorry. So I have already specified what will happen during this lab, and if you have downloaded the project, we will focus on the source code and start running the programs. So basically it has different classifiers, like bag of words underscore decision tree is basically running a decision tree classifier on the data. Naive Bayes is corresponding running the corresponding classifier. There is a one file that bag of words classifiers. It actually runs all the classifiers at once. So it may help you reducing the time for feature extraction part. So you extract feature once and run all the classifiers at once. Again, you have the data sample folder here, where you will be able to see the files that represents the particular instance for malware data. And again, we are focusing on the bytes file here, as we have seen before. You have a train labels.csv that maps the ID to the particular level on the data. Now, to run the program, we will follow the instructions in the readme text. So, basically it will, if you want to run a particular classifier like decision tree, you can run this command where you specify the training folder path and the labels file. Basically I will be running bag of words classifier py, so that you will be able to see all the classifiers output at once. We will be opening a terminal and copy this command, the following command. So, here we will be using all the classifiers, and the features for each instance we will be using will be bag of words. We will also have the TF-IDF classifiers, we will see later. Now, let us okay, sorry, yeah, I did wrong, yeah, sorry about that. We have to replace it with data sample, that is the folder where the data is stored, and the label files. Yep, thank you. It will take some time, as before we are extracting the features and doing the classifier. So, how it looks inside, let us see. As we have already seen, we will focus on the main portion of the code, where we extract the n-grams first. It only returns the byte 1 grams and the train labels now. Then we run specific methods for specific classifiers. All of them are almost similar. So, we will go for the decision tree method. It uses the tree.decision tree classifier from scikit-learn. To be able to see from scikit-learn, it is using the decision tree classifier, and it is again doing the cross validation score. But this time it actually calculates the accuracy with a variance. So, it has a mean accuracy and the variance. So, if you are running 5-fold cross validation, it will show you the mean of the accuracy of all the 5 values, and it will give you the standard deviation times like variance. Similarly, you can also run the TF-IDF classifiers to see at once, but you can also go run the particular ones, like you can run the TF-IDF decision tree to see the output of the decision tree. I think we will wait for the output to come. Actually got my output from the, so during decision tree classifier, it has an accuracy of 79% with a variance of 0.19. for naive Bayes accuracy is 0.72 with a variance of 0.08. For SVM classifier, the accuracy goes up to 77.77, again with a low variance 0.09. Now, we will run the TF-IDF classifiers. Which is basically this file. Again, here the extracted features will be the TF-IDF, and it works similar manner as we have done in the previous section.